thank you for that distinguished sounding introduction. It's a long list of things. Thank you for reading them all. It's true. We're doing a book with Princeton Architectural Press called Expanded Practice. It is a monograph book, and we feel it's a little bit premature. But we're doing it nonetheless, and actually doing the book sort of got us thinking about the work, and it's not a bad idea to sort of do a book in order to sort of figure out what it is that you're doing. So it sort of unleashed a kind of sort of soul searching in terms of what is the kind of work that we do and what does that mean for architecture. Oftentimes we're cast as lighting designers or interaction designers or furniture designers or clothing designers. But we are trained as architects, and we tend to sort of migrate across these kind of disciplinary borders fairly fluidly. We think fairly productively. And so doing the book is a great way to kind of try to make sense of it all. And it's not something that sort of was by design. It kind of emerged from opportunities, from possibilities, and some unsolicited projects that we sort of pursued on our own as a kind of research stream. So we're going to show you some of these things and hopefully make sense of some of the diversity of work that we're doing. The term expanded practice evokes a kind of Rosenkrauss understanding of disciplines, and I think it's something that we're sort of thinking about a fair amount, particularly well, we talk about discourse and disciplinarity, but now given the economy, we talk about survival. And somehow positioning yourself and your work and the kind of work that you do, maybe diversity is a good thing. Maybe you can sort of survive longer if you're somehow expanded or multidisciplinary. So we're going to show you a few of the kind of themes that cut through the work. They have funny names like envelopes and formats. But let me just start. So we like to show this because this is our publicity shot. This is our office, and it looks very clean. It's daytime. Everybody's working. The office is clean. This is kind of what it looks like. Usually it's nighttime. It's a huge mess. Nobody's. Well, the same people are there. Anyways. We treat the studio as a kind of a shop, as it looks kind of like upstairs, actually. We like that. It's messy, there's fabric, there's sewing machines, there's wood, there's saws, there's all kinds of stuff, there's some computers. But we do treat the office as a kind of place to do studio-like investigations with material, with computers, and we'll show you some of that sort of productive exchange.
Yeah. So when we were asked to do this monograph, the first thing we did was we took an index of our projects, and we basically cataloged them in every possible format. So we looked at by type or by theme, etc. And then we found that it was actually most interesting to organize them by, let's say, thematics that actually tested an idea across different scales. So to break up the typology of clothing versus book versus building. One of the first projects I'm going to show is in the series that looked specifically at surface, which then became later envelopes. But I like to show this Rudovsky slide, which shows a Japanese garment on the left and a Western garment on the right, and the difference between them, where one deals with the idea of the body and form through a kind of emphasis or bias towards material production. So based on the width of the cloth, things like curvature and size are taken up by the fold or wrapping or layering, and the right privileging the body, and then you see the kind of residual pieces of material that are kind of considered the leftover. So this kind of instigated a project called the Mobius dress, which basically looked at a literal Mobius strip, which is a topology with 1.5 twists. And it looked at actually the unraveling of the Mobius strip, because what's very interesting about this compact manifold is if you follow it along its kind of perimeter, it actually has this splitting function where it creates a longer loop, which has 1.5 twists, and then another loop which intersects it. So the Mobius dress was essentially the idea of how you could wear this inside-outside surface, and it would essentially be structured by the body. And as it unraveled along this very, very super long zipper, it actually kind of transformed in terms of its form in relationship to the body itself. So it's a dress worn to be unworn, essentially. But the studies for the Mobius dress looked at basically a loop with a half twist, a loop with 1.5, and then a double loop. And then again, the operation was through the zipper. And then in terms of the material, thought it was important that it have no warp and no weft, so it's made actually out of industrial recycled felt. And then another project which kind of built on that one was also looking at the idea of a continuous surface, but in an interior space. And I was asked to collaborate with Enrique Norton on a project at the Guggenheim for the Aztec Empire Show. And the project was basically to design an armature to hold 400, a little more than 400 objects. And the objects varied from 2 tons to 2 centimeters in scale. And the organization was determined actually by a curator. But the first thing we learned was that the objects actually didn't fit in the rotunda if you kind of went straight up the perimeter, so we had to create surplus surface. So we undulated the surface in and out of the bay system within the Guggenheim to create extra length to house all the objects. And because there was such a massive quantity, we thought it would be useful to think about one surface that would accommodate all the objects, but through very localized rules. So basically each object is tagged from the beginning with where it's being lent from, and the institution which lends the object determines whether it needs to be behind glass, can be out, needs to be thermally controlled, etc. So all those criteria were understood, as well as kind of the scale of these objects. Some of them weighed so much you actually had to distribute load, etc. So what we did was we just made a basic tool which allowed us to put all the objects in the space and then assign them the kind of parameters that were specific to the object. And then as a design tool, we could organize these as the curator wanted them. We could suggest alternate ways of doing the sequencing, etc., and then use this as a back and forth design tool with the curator to look at the total kind of spatial manifestation of these ideas. So the actual project materialized in felt, and we used a very dark felt. It's a dark brown black, which was custom created to kind of counteract the whiteness of the Guggenheim. But we also wanted it to be this kind of thick felt such that it kind of absorbed not only the objects, but also light and sound. And so it creates this kind of deep, dark, mute envelope against the Guggenheim interior, but it also absorbs sound, which was pretty interesting because the Guggenheim is an extremely live space. But in this condition, it actually, the change of the sonic qualities affected your understanding of its spatial qualities. So here are some views. These are like the objects that have to be behind glass. And in the end, the curator determined the sequencing. Here you can see how each object is basically has a custom pocket, we call them, like pocket parameters, and then there's a rule about the transition between the different pocket shelves. In the end, it was actually drawn as opposed to press a button and there it goes. And we tried to be efficient about the radii, etc., even though every shelf was custom so that it could be built a little bit more efficiently. The other thing about the pockets were, in addition to pockets for the actual objects, there were spatial pockets, which created these kind of mini galleries. So if you went back into them, it was pretty amazing, like you lost the live sound of the Guggenheim itself. And then, I think I took those out. But on the top level, like the most difficult thing with the Guggenheim is the top floor and how you deal with that. So some people come up, walk up. Some people take the elevator to ramp 5 and then walk down. So the exhibition had to work in both directions. But at the top, we wanted to, if you walked up, to make the experience continuous. So it's the moment in which you can occupy both sides of the wall. And you actually walk up on this back side, and then you come down on the front side. Is there a pointer here? So basically, you come up this side, and then you walk down that side. So spatially, in terms of circulation, it creates that continuous loop condition. And then this is where we created the environmental vitrines, which are the ones that had to have specific thermal properties. And we actually use that condition where you have to go up right against the edge of the felt to see these precious objects. And that thickness or that depth actually created the lateral stability for the wall itself.
Okay, so a couple years ago we were asked to participate in the PS1 Young Architects competition, and I'm sure you're familiar with this. It seems to be a kind of testing ground for young architects where they kind of throw themselves at this site, and some of the most memorable ones have been done by Shop and Hernan Diaz Alonso and architects, people that we admire. We were thrilled to compete. PS1 is a museum in Queens for contemporary art. They have a large courtyard, and that's the site. And every year they fill it with some sort of scaffold, kind of architectural scaffold for activities such as that. So when we took on this task, we decided not to try to make an object. Typically, these sort of advanced architectural artifacts take on a kind of sculptural quality, and we wanted to refuse the kind of sculptural. So we thought about a kind of field or a fill or some sort of casting. We plotted some data points, and then we used those data points to create a kind of three-dimensional Voronoi kind of cellular aggregate, which we abstracted into a series of vertices and then stylized them to create this form. This form takes its geometry from the courtyard, so it's actually not an object. It's an immersive environment, and we really wanted to create something that could enable different behaviors. Like there's room for sitting and sunbathing, and there's always some sort of water element. There's dancing. So this is the kind of jungle-like space. It's sort of emphatically not an object, and it's diffuse, and we said it's 100% open, although it's also 100% full. So it has a kind of quality of a foam. And we were looking at kind of structures that had these properties, like soap bubbles and so on, and the kind of, not in terms of image or geometry, but the kind of economy of material that goes into a soap bubble, the way it kind of nests and presses against other soap bubbles. So that was kind of an ambition for this, to create this sort of foamy, bubbly interior environment that, the rules are it has to provide shading and seating, so we thought we met those requirements. It also has to provoke kind of euphoric funness. So we were working hard at that with architecture. So we showed them this, and we thought, surely we would win. But no, sadly we didn't. But it was a 2-month research project for us, and this was a kind of encounter for us with a kind of material exploration. We started with paper models and bending paper and seeing what kind of radiuses we could make, nesting them together. We looked at seating elements. It seemed to be about a kind of lounging space, and what kind of geometries could we take from the body that would promote a kind of languid lounging. We worked back and forth between paper models and the computer. Here, Meejin's sort of unrolling a rhino model. But we learned a lot about this because in paper it's very easy to create compound curvatures. In the computer we found some of those shapes didn't come so naturally. So using scripting, using material in the kind of productive exchange was the kind of breakthrough for us in this project. This is polypropylene. It's a plastic we discovered that's recycled, heat moldable. Here we are sort of molding it in the oven, forming it around these wooden molds, clamping it in place, and producing the kind of cell. So something that began with paper, went through Rhino in a kind of unfolding process, but ultimately ended up back in a kind of material reality, trying to prove how the material could be molded and create this kind of loungescape was the interesting thing for this project. And when we were devastated by not having won this one, but we continued to make these things, and so we tried different geometries and different kinds of inhabitations. We call these loop chairs. They're similar to the Mobius dress and the Guggenheim. I mean, they're concerned with a kind of continuity of surface, a kind of material surface, but also with a very spatial quality. We're not furniture designers, we're architects, so I think even as the Mobius dress refuses kind of interior and exterior, I think these things produce both a chair and a kind of interior in a very banal sort of definition of architecture.
So the next set of projects kind of look at the idea of interaction and our design research in that area. One of the first projects that kind of studied this was called the defensible dress. And basically it was a garment to protect one's personal space from people who were infringing on that personal space. It's an interesting project for us in that it had 3 iterations. The first one was pretty primitive, using servo motors and a microcontroller and a sensor. But then, we actually redid the project a couple years later with a different material. We used nitinol, which is a shape memory alloy. And basically, there's no servos, there's no motors in this thing. And what's happening is, when the sensor detects someone has invaded your space, and you can actually calibrate and control what you define as your personal space, then there's an electric charge, and that electric charge actually heats up this tiny wire, which then contracts, and so that's what's creating the kind of lever action and lifting up the pines or quills. And that project actually, the research in that project led to a project called White Noise, White Light, which we were very fortunate to win. It was an invited international design competition. I don't know why we were invited, but we proposed a field essentially, very, very simple and straightforward, that would kind of respond to the body as it moved through it. The idea was that this field would occupy the landscape, but instead of being, let's say, choreographed to behave as one whole piece, each fiber optic stock, which is transmitting white light from a set of LEDs below a raised deck, would also emit white noise. And the idea was that it was all about accumulation, but a kind of accumulation, so the definition of white as the accumulation that actually creates a kind of homogeneous condition. And so here basically each stock has a a sensor, and it's responding locally. They're not networked together. And so it's the public that's actually choreographing the effects in this field by their kind of movements through it. These were totally staged. I mean, we were wandering through this thing like in a perfectly choreographed way. But what was surprising was how it was used by others, and you will see like it never worked the way we had imagined, because in fact, the public was very hard to control, and there were a lot of people in the field. So what became actually very interesting about that project was in the end, we realized we were actually just providing this kind of infrastructure for the public to inhabit, and that public was finding all sorts of interesting ways to use that field. So from trying to break it to running through it or congregating around it or in it, etc.
Somehow we got into this sort of niche of electronics and interaction, and someone who had seen the project in Athens asked us to do a permanent installation in Washington, D.C. So here's the White House, here's Vermont Avenue, and the site was this kind of empty piece of sidewalk in front of an office building. And the office building looked kind of like this, and he said, can you do something here? And we said, sure, of course. So we went back and we were thinking, like, what would make this sort of empty piece of sidewalk into a sort of dynamic public space? And some of the lessons that we learned from Athens were that all you had to do is provide a kind of minor form of intelligence in the material that could react to unexpected behaviors, and they could provoke all kinds of new behaviors. And so we proposed two things. One is this what we call the sound grove. So this was also interactive in that as you touch it, it lights up and it triggers different musical notes. Each stock is a different instrument, each segment's a different note. And so the idea was that, like White Noise, White Light, the public would come through and sort of play it on their own. But it uses different technologies, and I'll show you some of that. Our hope was that this would transform the public space in front of the building and sort of reposition it as a kind of public space project. The other part of this was what we call the light stream, which is this sort of vitrine which has an LED pixel net in it. And this was also a kind of, we were thinking about the public realm, and in Washington in particular, after 9/11, there's kind of obsession with surveillance, with control. There's cameras everywhere. We thought maybe we could take some of that feed from a surveillance camera and broadcast it back into the public, so that the public would sort of understand themselves as being within the kind of field of surveillance, but also entertain a kind of playful interaction with the kind of digital shadow. So this is the second part. The light stream part is partially a kind of building signage. That's what the client wanted. But into that, we kind of smuggled this other kind of idea, which was about this kind of playfulness, this kind of ability to overwrite the kind of official content from the kind of commercial sign. And this took the form of a lot of sort of research and development in terms of the electronics themselves. Okay, so we had this idea, we pitched it, we didn't know quite how to do it, but we were confident that we could figure it out. And we said a pixel net, surely there's one out there, but there wasn't. And so we had to sort of try to figure out how to make one. And so this is a little piece of sort of custom electronics. It's an extruded aluminum piece which has two LEDs on it. There's a flexible circuit board on it, and this little white piece of plastic clamps the wire, and so the wire both holds it up structurally, it sends power to it, and also addresses it. So with these 4 cables, we can actually create one strand that's fully addressable as a LED screen, essentially. So we did a lot of R&D. This is Will Pickering in Brooklyn, sort of testing out these strands. We custom fabricated all this stuff, about 8,000 pixels, and they are sort of here suspended. The thing about it is you can see right through it, and so there's plenty of LED products that you can put on an opaque surface, but if you want to do a kind of transparent surface so that you can interact with someone through the screen, you kind of have to make your own. So that's what we did. Oh, this one's out of sequence.
You know, the other thing about what we call low res, which is the LED pixel net, was that Color Kinetics actually produces something like that, but it was like a Christmas light, and it was our desire to not use a product but get it to be exactly right that forced us down this path of creating our own kind of LED double-sided pixels. That was the conundrum. We couldn't find anyone that produced a double-sided pixel. This is just a diagram that actually shows that here, unlike white noise, white light, the poles are networked together. So as soon as you trigger one, all the other poles know which other one has been triggered, and actually it triggers another one in the field. So it tries to envelop or move the sound around to create a kind of enveloping space. And this was also a design build project. Our fabricator totally flaked on us and just skipped town. So we were stuck trying to produce this thing ourselves. These are the donut circuit boards, and they have to be donuts because they have to fit between an inner structural pole and an outer capacity sensing pole. And this is my parents' garage. That's the brain of the thing. And basically, we had to kind of assemble this thing ourselves with assistance by some electronics engineers. But in the end, we after a lot of pain, we were able to get it done. And I think what was really interesting was, the question of, will people touch things in public space? And what we found to be interesting was, like, kids, they know that they're supposed to play in it. And this girl was, like, running around, and then I think her father comes a little bit later and yells at her and says, "Don't touch that." I can talk about Hover. So we were also asked, so our projects range in scale clearly, but also in budget. So we were asked if there was anything we could do for $4,000. And it was asked to us by the New Orleans AIA after Katrina, and so we said, sure, there's something we can do for $4,000. And it was part of this festival called the Décour Festival, where they wanted to bring the public back to the French Quarter. And so they asked different artists and architects to produce temporary installations for like between 10 and 20 days to activate these private courtyard spaces, which were turned over into public space by the private owners. So we decided we wanted to do something off-grid. If we were going to build something in New Orleans, we wanted to make a kind of comment about being off-grid. And so we created this solar-powered canopy using basically flexible photovoltaic film. This is the site. And everything was kind of ready-made except the small microcontroller because we were on such a tight budget and tight time frame. So it basically is a flexible photovoltaic film, a microcontroller LED rope light, and some rechargeable batteries. That's the controller, which actually is pretty intelligent in that it allows the PV to be acting as the sensor. So when the PV is no longer absorbing energy, then it informs the microcontroller knows, and therefore turns the lights on. Because we didn't know what site we were going to get, we looked at kind of just some way of tiling something. So we looked at a pentagonal tiling system, which seemed very efficient. But then we also looked at the kind of solar angles, which required a kind of bias to that pentagonal tile. And so there you can see one up in the day, you can see the PVs sort of in shadow, and then the effect at night. And it basically indexed the weather in that based on where it was on the site at night, basically these turn off when they just lose their power. So based on how much light they absorb during the day is how long they can last at night.
Okay. This is one of the kind of questionable chapters in the book. It's called Natures, and we really had no other ideas for what to do with certain projects, so we call them Natures. And architecture, nature, architecture produces a kind of habit, domesticating sort of behaviors. It's something that we're kind of interested in. We had a number of projects that dealt with domestic environments, dealt with sort of conventional understandings of the urban and the natural. This one was a collaborative project that was done probably for $10,000. It was by 10 architects. We worked with 10 other architects on this. We wanted to do something together in Boston. We got together. We couldn't agree on anything, so we did something like this, which is what do we know nothing about, and what do we want to know something about. So we had seen these kind of vertical gardens in Europe, and we thought, let's find out how to do that. So we proposed this idea. We tried chia, which will grow anywhere. It's amazing, but it only lasts for about a week. We were testing different. We had all this leftover felt, so we were testing growing different varieties of grass in felt with Miracle Grow and other things. In the end, we found this product called sedum. You can get it. It's for green roofs. It's fairly hardy, and we had run out of time. So we used the sedum and we kind of stitched it onto this mesh stuff, and then we hung it up with these stainless steel cables. It was a kind of fun project. It was design build, which we swore we'd never do again, but it was a way to sort of do something quickly and effectively and try a few different things. So the idea of a vertical park, you're sort of tipping the landscape upright. Somehow it has no footprint, so we got permission from a building owner to install this thing on their building. They loved the idea of sort of free publicity. But it was something that we were interested in and we wanted to test. And so it's not a kind of thesis about nature, it's more a kind of deployment of a kind of unusual nature, maybe. And there it was. It was only temporary. It was actually for the AIA convention in Boston last year. It lasted 3 months and it bloomed, which was kind of cool. So that was a way to lead into this project, which is a domestic environment. It's a loft building in Boston. It's on the top floor, and the idea was to sort of bring the sky into the loft. So you're on the top floor, maybe you can pull down a piece of the sky. And this was something, it was for a couple, they had kids, they wanted to live in the city, they wanted to raise their kids in the city. They had incredible pressures from their peers about raising their kids in the suburbs, but they were from New York and they were committed to the city. So they asked us to design their loft, and you can see the plan here. It was a symmetrical, there were 2 apartments that they put together, and the core's in the middle, so we said, why don't we add some of these light courts? So we carved a big hole in here, removed about 100 square feet, and introduced that courtyard. And so this is their kind of, we call it a kind of cube of nature. In the winter in Boston it snows a lot, and you get a lot of snow in there. So they don't have a yard, they don't have a kind of suburban yard, but they do have this kind of cube of nature. There's Eleanor. And that's their bedroom has this kind of, we call it a light fixture, but it's really the bathtub under a skylight, sort of transforming a kind of domestic piece of plumbing into a kind of spatial effect machine.
I think what's interesting about that house was introducing the weather into the kind of 3 volumes and also utilizing the daylighting. So because of the bathtub and the shower, those spaces are actually adjacent to the bedroom and the office, and so they receive a lot of natural light in the core. Since, like most urban buildings, they only have windows on the front and the back side. The next project I'm going to show also deals with kind of nature in a way, in that we were approached by the city of New Bedford to look at a community boathouse in order to bring the public of New Bedford back to its waterfront. So the Acushnet River was the largest Superfund site in the United States because of the PCB pollution in the river. And they've been dredging it for many years, and it's still a few years off, but the plan is to bring the city back to the river and to plan for a community boathouse. So this project was first taken on as an academic studio, and then it became a office project, and then it went back into the academic studio. But what happened was they just needed a simple structure to store boats, but also the idea of creating a kind of public terrace or public dock to inhabit. So the landscape basically essentially peels up, creating a giant roof so that you can watch races as they go by. Below it's very straightforward. There's enough for the actual boats, and then a simple community space. And that project, I think it's a couple years away, and we did the pricing drawings for that last year. But I think the students and we also felt impatient, like they're going to have to raise the money. It's going to cost between $3 million and $5 million, et cetera, et cetera. But people can actually use the riverfront now. So what can we do? So we proposed to the city that through a design build workshop at MIT, we would actually create a kind of floating landscape that you could still launch boats off of. And so the idea was to create a kind of reconfigurable, modular, floating pod that could stack linearly so that you could launch a boat that was the appropriate length, but you could also cluster them into a smaller landscape. So I've never made anything that floated, so this was the first experience with that. We used aluminum pontoons, and we basically essentially laser cut the whole thing out of aluminum, assembled it, and then floated them down the river. So we thought it'd be really interesting to float them from MIT down to the Acushnet, which actually takes a long time. In the end, we didn't do that. We had to take them on the road and then dump them on a waterway nearby and then bring them down. So here you can see how the pods configure. This is not the actual site. In fact, they're kind of sightless because they can go anywhere. But we had to prove that it worked and it floated and did, load tests. And this is our testing in the marina to prove it floats. So the last section is called formats. And basically it looks at what we're loosely calling formats because they deal with either packing program or kind of conundrums about organization. So we were contacted by a couple, not this couple, but like a couple. They're a little younger than my parents, and they have a son and a daughter, and both the daughter's about to get married, the son's married, and they basically came to us and they said, we want to build a house that brings our children home. We want our children to come back and live with us. And we said, okay. This was before the recession, so we're like, okay, that's interesting. And I think it's a cultural thing. They're Korean, and so, multi-generations under one roof is not unusual in the context in which they grew up. But they could understand their children's need for privacy, etc. So what we propose is basically packing 3 houses in one because of the site, it's zoned for single-family residential, so the house couldn't look like 3 houses packed in one, but it needed to somewhat operate like one. So the idea was essentially like to create these kind of row houses with sort of party walls. There was a very tight budget, so we needed the kind of minimum footprint and minimum volume, and so what we looked at was just the relationship of the garage and the relationship of the view, and just created a manifold between those two. So the idea is there's a garage for each one of the family members, so the son, the daughter, the parents, that you would actually come in through the garage, and everyone would go through their own kind of corridor, and then into the kind of public spaces of the house. And then later, when you wanted to go to bed, everyone would actually have a separate circulation up to the second floor. So you could never go from here to here, brother's room to sister's room. You'd have to go all the way down, probably put some security system, I don't know. But that there would be a kind of bigger sitting room space, and then the 3 bedrooms. But we thought it'd be interesting to, create this zone. So like if you had to, you could go out and knock on this glass window. So it creates a little bit of tension, but for the most part, it creates enough privacy that they could live together. The site and the section, it's near a creek, an exterior view. So that was, that project actually, we just finished the bid drawings and got the pricing back for, but it doesn't look anything like this anymore because the children saw it and they said they didn't want to live in it. They wanted to live in a much more, I don't know, boxy, modern house. So, and that has some interesting things in it too, but we're not going to show it.
So this research theme is format, and one way to think about format is typology, like the single-family house or the row house. This is another way to think about format, and this is a project we're doing in China, where they asked for something we'd never heard of, which was a kind of a VIP entertainment complex or something. And essentially, it's a 20,000 square foot villa for somebody to entertain their guests, to have their business in, and to live with their family. The rules were it must be contain courtyards, and it must have a sloped roof.
By the client. Not by us.
Yeah. So the client said it must reference sort of traditional Chinese courtyard houses, and we thought, cool, a mat building. So we thought we could turn that sort of typology into something interesting as a piece of research. We looked at the traditional courtyards, and we looked at the kind of way that they grow over time, the way that they pack together, the way that they sort of focus inward and up at the sky. We thought this was a very interesting type to try to work with. We proposed something that was kind of cellular, sort of packed structure, where all these roofs are sloped, but the top of the whole thing is this kind of horizontal plane. So we produced a kind of flat top, but locally there are all these kind of cone or inverted pyramids that reference a kind of sloped courtyard roof. And this is what we proposed. There's a zone that's for live with the kind of big boss man with his family, and then there's the kind of entertainment zone, and then there's the office area, sort of focused around these different courtyards. So this was a real challenge to kind of work within a kind of building tradition, which recognizes and insists on a kind of legibility of form and type, which is the Chinese sort of courtyard house, but trying to sort of update it and trying to make it sort of interesting geometrically, formally, typologically for a more contemporary audience. So this is going forward, and we're actually working on the drawings for this right now. Here's another version of it where the top actually started to pitch. So there's 2 cuts, one sloping this way, one sloping that way. So we lost our flat top, but locally all the roofs are still pitching towards the centers. We had to do these interiors to show the materials. And actually, one of the things that we found very interesting was going there and looking at the the building traditions, like these. And there is, I think, a kind of interest, a contemporary interest in pattern and ornament. There's a kind of resurgence of an idea about complexity, and all those things you do find within these sort of traditional types. So if you look at Chinese screen traditions, there's incredible complexity to their kind of geometries as they sort of intersect. So we were asked actually to look at those things and sort of reinterpret them. So we looked at three particular ones. This was for the building, but also for an exhibition in Shanghai. So one, okay, here's the type. Maybe we could sort of transform that into a kind of gradient of sort of opaque panels and sort of dissolving panels that would sort of stack on top of each other. Another one might take a kind of repetitive vertical, something you might find in a kind of rafter condition, and sort of transform it through sort of shifting sort of pivot points or variables within it. And the third was sort of taking these incredible sort of geometrical sort of overlaps and sort of spatializing them into these kind of nested figures. And these are all things that would have to be built in China, sort of without CNC mills, but with a lot of labor.
Okay, so this is the last project we're going to show, and it's also a publication project, and actually maybe Eric, we can just do this one together. So we were asked to be on an advisory council 2 years ago to study 3 parcels along the Big Dig. They're parcels like 19, 20, and 22 or something.
Can I just say, we live in Boston, and in Boston there was this incredible highway that sort of carved through the city. It was called the Green Monster, and it was put in the 60s, and it destroyed a huge swath of the city, and it kind of cut the city in two. It is a kind of American story, the kind of American city of the 1960s being sort of cleft by the highway. And you may have heard, they spent $13 billion to take it down and bury it, and they call it the Big Dig. So it's the largest sort of urban infrastructure project in U.S. history. It sort of happened right outside of our windows, and sort of looking out the window at the sort of transformation of the city and the kind of promise of a kind of sort of connected public realm was the kind of impetus for this project.
That's good. I was going to say that on the next slide, but we were asked to look at 3 of these parcels, and the way it worked was there were thousands of engineers, et cetera, to plan and coordinate the whole Big Dig. And there was one person, apparently, only one, in charge of the surface during that whole time period. So as the Big Dig was nearing its completion, they hired different landscape architects to deal with it purely as a surface condition. And we were asked, as part of this advisory council, to propose some interim programming for 3 of the parcels. And it just got us thinking so much about this project and all the potentials that will never happen because of this kind of separation between the infrastructural or the traffic engineers versus the landscape architects versus the architects. So we proposed this book called Unsolicited Small Projects for the Big Dig, and we got a small Graham grant to start it. And what we did was we just began by learning about our own city. So Boston is pretty much all landfill. So you can see the 1722 context of Boston and how Boston has just kind of grown and expanded over time. And then these are kind of images. The left is actually of the Green Monster when it cut through Boston. The right is of the Big Dig, or essentially what needs to happen in terms of rerouting all the traffic so that it can then go under the city. So here's an image of the Greenway. So that's the tunnel that goes underneath, and these nice green landscaped parks that have appeared in the city, and they're fine. We like them, but it seemed like there were some opportunities that we thought were worth kind of speculating on. So one of the things was, basically, even though it connects, and graphically they always draw it so it looks like it kind of connects all across and creates this like great linear park, but there are so many interruptions that nobody actually jogs along this park, etc. The other thing that's interesting is when they dug the tunnel, they had to keep the elevated highway operating the whole time. So basically, they're digging under an operational highway, and so they had to create these giant slurry walls that actually could carry the load of the elevated above. So there's the Big Dig is essentially overstructured because it can carry an elevated highway, which it no longer has to carry. So that seemed kind of interesting. It carves 155 feet below the city at its deepest point. It also, of course, removed a lot of earth, and a lot of it went to Spectacle Island. So you can see the Spectacle Island, which is in the harbor, and it was the nearest place that they could kind of dump the soil. So you can see how over time also Spectacle Island has changed, and then here's the section, pre-dig and post-Big Dig. And we looked at how landscapes in Boston had traditionally had infrastructural or ecological roles, essentially acting as a sewage system or for allowing sheep to graze, etc. And then we looked more specifically at the Big Dig and the hardscape, softscape, etc. And one of the things we proposed was, do you want to talk?
No, I wanted to say something. I mean, the Greenway kind of emerges at a time where we're sort of reconsidering the notion of green. The idea that you could find a pristine site anywhere to build on seems to be a thing of the past. Sites now seem always already occupied by some use. And so the idea of looking at urban sites not as sort of in any way pristine, but looking at sort of the kind of always already in the process of remediation was a kind of condition that we just sort of found prevalent. And so there's notions of, well, how do you reoccupy a site like that, and it's the desires of a site to be both, playing field, a kind of highway, and a kind of park simultaneously led to a kind of speculative project that might sort of playfully reconfigure that condition. So these projects were unsolicited and probably unbuildable, but we looked at a sort of tri-panel system that could sort of switch, sort of play different roles, both hardscape, softscape, and something else. We also looked at some of the kind of the debris, the park system or the tunnel system as this kind of infrastructure in the city. We kind of repress the kind of infrastructure within the city, but it sort of erupts in these ventilation shafts, which are decorated with architectural motifs and protected with jersey barriers. And somehow that seemed like it was sort of begging for some sort of architectural or some sort of transformation.
I mean, the amazing things about these exhaust towers is, this is actually one of the smaller ones. There's one that's actually encased in the Intercontinental Hotel. So the Intercontinental Hotel looks like it has 2 glass towers. One of those towers is actually a ventilation exhaust shaft for the Big Dig. So everything is kind of being hidden, and we thought, we understand the need to actually deal with the kind of mechanical issues of the tunnel, so why not utilize that or harness that in some way? So we proposed maybe we could use it actually for energy, and there could be these kind of piezoelectric things that through their kind of micro vibrations would collect energy as the airflow kind of moved up and through the shaft. The other thing is we index all the technology involved in the Big Dig, which is pretty amazing. So they put in these loop detectors, so as a car drives by, it can track your speed, of course. There's a ton of surveillance equipment underneath, etc. But then the landscape part is totally, benign. Banal and benign. So we thought you know what we need for the joggers? We need the joggers Easy Pass, where they can put an RFID tag on their tennis shoes, and as they run, it'll change all the don't walk signs to walk signs. So then the cars then have to have a kind of reverse experience of the Greenway, and the Greenway becomes more privileged to the pedestrian. And then also tied in with the RFID tags on the shoes, there would also be these moving trees, which would also make sure that you never actually see the cars, because as you jog, the trees would move with you.
There's some details to work out here.
Yeah. The other thing we looked at was the furniture. So the book basically catalogs everything that we think deals with public space. And these are all the benches that are along the greenway. I don't know who designed these benches. But we said, like, this is kind of a problem that all these benches look this way. What if there were other kinds of ways of inhabiting or sitting or lounging in the green space, from giant public multi-person seesaws, but also dealing with like the issue of the soapbox, and maybe these things could create stages and flip over to create chairs, etc., to kind of occupy this public space in a different way.
Okay, so that's the last project, and I think just thinking about practice today, how do you sort of position yourself vis-a-vis architecture, landscape, art? The last project we showed is a kind of speculative project that there's no client, nobody called us and said, could you do this? It was something that sort of emerged out of a kind of curiosity, a kind of dissatisfaction with the built environment, and we sort of launched into this kind of research project, which was kind of fun and funded by some grant money. But I think the thing that I think is important to point out about some of this work is that a lot of it is sort of self-motivated. Sometimes there's a kind of a curious technology that we don't know too much about, but we sort of want to sort of figure it out, and so we'll embark on these projects. I said we're architects, but we sort of emphatically cross disciplinary boundaries whenever possible. And I think book design or landscape, we played the different roles. And so I think the thing to say, particularly in this place, is the kind of disciplinarity is something that could be productively challenged or expanded or evolved. Okay, that's it. Thank you.